You are welcome, everyone. In this video, we are going to be looking at solving problems that leads to simultaneous equation, indices leading to simultaneous equation. And the problem here says 2 raised to the power of x plus 1 equal to 8 raised to the power of y minus 1. That's the first equation given to us. Then the second equation says 4 raised to the power of x equal to 2 raised to the power of 2y. Find x and y. So let's quickly look at the first equation solution. So the first equation given to us is 2 raised to the power of x plus 1 equal to 8 raised to the power of y minus 1. So what we need to do here is make 8 have a base of 2. They should have common base. They should have the same base. And 8 can be written as 2 raised to the power of 3. Because we have 2 times 2 times 2 is going to give us 8. And that's what we're going to be applying here. So we have 2 raised to the power of x plus 1 equal to, then 8 is written as 2 raised to the power of 3. Don't forget, there is still another power there, which is y minus 1. So we have y minus 1. So which is going to be equal to 2 raised to the power of x plus 1 equal to, then I'm going to be using 3 to multiply y minus 1. Don't forget the law that says when you have a raised to the power of b, then raised to the power of c, you multiply the powers. So it becomes a raised to the power of b times c, that's bc. And that's the same law we are going to be applying here. This is going to be 2 raised to the power of 3 into bracket y minus 1. That's 3 into bracket y minus 1. So which is going to be giving us, okay, let's leave it this way. So since the base are the same, so since they share the same base, which is 2, common base 2, we are going to be equating the power. So we have x plus 1 equal to 3 into bracket y minus 1. So from here we just simplify. So we have x plus 1 equal to 3y minus 3. And of course we can make x the subject of formula, or we get equation 1 from this. So which is going to be equal to x will be equal to 3y minus 3 then minus 1. So that means x equal to 3y minus 4. So we have an equation already. Let me call it 1. So it says x equal to 3y minus 4. Now we're going to be using the second equation given to us to get another equation. So from the second equation given to us, so from 4 raised to the power of x equal to 2 raised to the power of 2y. Of course, I can write 4 as 2 raised to the power of 2. So that's what I'm going to be doing here. So instead of writing 4, I'll write 2 raised to the power of 2. And of course, there's another power, which is x equal to 2 raised to the power of 2y. So which is going to give me 2 raised to the power of 2x equal to 2 raised to the power of 2y. And as you can see, the bases are equal, so we equate the power. So we can say 2x is the same thing as 2y. And from here, when we divide both sides by 2, we discover that x is the same thing as y. So we can say x let me write it down here, x equal to y. So we know now that x is the same thing as y. Let me call this equation 2. So I have equation 1 and I have equation 2. So x is 3y minus 4 in equation 1. Okay? X is 3y minus 4. That's equation 1. And at the same time, x is what? Is y, equation 2. So I can equate both equation 1 and 2 together since the both of them are x. So that means they are the same. Hence, we can say y equal to, since x is equal to y, so I can replace the value of x here with y. So y equal to 3y minus 4. Then I can collect like terms. So collecting like terms, so I'm going to be having 3y plus y minus y rather, minus y equal to 4. So we say 2y equal to 4, and hence y equal to 2. So we divide both sides by 2. We discover that y is equal to 2. And since x is equal to y, so we can say also, since x is equal to y, then x is also equal to 2. So therefore, we can say x is 2, and at the same time, y is equal to 2. And this is how you go about it. Now let's try solving another exercise. Now, the question I have here with me says 2 raised to the power of x plus 1 plus 2 raised to the power of x equal to 48. Then the second one says 3 raised to the power of y equal to 27. Find x and y. Of course, to get x and y here, to get y is not the problem. So let's quickly get y. So it's just getting x. So, and of course, even the first equation, can be given without giving you the second equation. So you can only be given the first equation and they ask you to find x without involving the second equation. But since we are given two equations, so we are going to be finding x and y separately. So solution. So let's quickly get y first, because it's easy from the equation 2 given to us. So from 3 raised to the power of y equal to 27. It's easy to see that we can say 3 raised to the power of y equal to 3 raised to the power of 3. Because 27 can be written as 3 raised to the power of 3. 3 times 3 times 3. So from here, we equate the power, because we have both bases to be 3. So we have, therefore, we can say y equal to 3. So we have gotten the value of y without stress. So let us use the first equation now to get the value of x. And that is where we need to put more consideration into. Now, we have 2 raised to the power of x plus 1 plus 2 raised to the power of x equal to 48. It is also quite easy, because based on what we have here, you can see that there is a common term here. And the common term here is 2 raised to the power of x. So it's just like having, okay, let me put it this way. Let me split first. So splitting this, so I can write 2 raised to the power of x plus 1 as 2 raised to the power of x times 2 raised to the power of 1. Don't forget, one of the laws of indices is when you have the same base and there is multiplication. So it becomes what? 2 raised to the power of 3 plus 3. So I can also convert from this back to this, and which is what I did. I had to split. So 2 raised to the power of x plus 1 can be written as 2 raised to the power of x times 2 raised to the power of 1. So plus 2 raised to the power of x, everything equal to 48. And that's what we are going to be considering. And based on what we have here, you can see that 2 raised to the power of x is common. So we are going to be factorizing. Please take note, it's just like in the case of, okay, I can say let 2 raised to the power of x be p. So when we make 2 raised to the power of x be p, you can see that we'll be having p times 2, then plus p. Then we factorize. You can see that that's how you just go about it. So let me represent 2 raised to the power of x with a value. But if you don't want to do that too, you can also just factorize. 2 raised to the power of x is common. So I can say let p be equal to 2 raised to the power of x, such that we'll be having p times 2, that's 2p, then plus p equal to 48. And 2p plus p is 3p. So we have 3p equal to 48. So what is going to be our p? P is going to be 48 divided by 3. So 48 divided by 3. And that's 16. So if p is 16, then how do we get x? Then we come back, recall. You have to recall that our p is 2 raised to the power of x. That p is 2 raised to the power of x. That's what we represented p to be. Then we now bring it back. And also p is 16. So I can say 2 raised to the power of x equal to 16. Because p is 16 and at the same time p is 2 raised to the power of x. So that means 2 raised to the power of x is 16. And of course we can easily get this done. So we have 2 raised to the power of x equal to 2 raised to the power of 4. Then we can equate the power because the base, they are the same. So therefore x equal to 4. And as you can see, y is 3, x is 4. So but as we solved both of them differently, we are not solving them together. So we solve them differently. And that's how you go about this. Let's try another example. So in this example, we are only going to be solving for x. So it says 5 raised to the power of x plus 5 raised to the power of x minus 1 equal to 150. Find the value of x. So it's just almost the same thing as our last example, our last exercise that we just solved. How we were able to get the value of x is the same way we're going to be getting the value of x here. So just applying the same procedure. So what do we do here? We have to split 5 raised to the power of x minus 1. And don't forget, like I told you, when we have a raised to the power of b divided by a raised to the power of c, it's going to be giving us a raised to the power of b minus c. And also when we have a raised to the power of b multiplying a raised to the power of c, it's going to be giving us a raised to the power of b times c. So we are just going to be considering this second one, because what we have is x minus 1, that's the power. So which is in line with this second law here. So we are going to be taking it back. So since we have this, we are going to be splitting. So solution. So we have 5 raised to the power of x plus, so I'm going to be splitting this. It's going to be 5 raised to the power of x, then divided by 5 raised to the power of 1. Don't forget. So this is what helps us to get 5 raised to the power of x minus 1. So we have 5 raised to the power of x divided by 5 raised to the power of 1. And it's going to be giving us 150. It's going to be 150. Now what do we do next? So as in this case now, we can use the same procedure we have used in the last exercise. We can say let p equal to 5 raised to the power of x. So let's do that. Let p to be equal to 5 raised to the power of x. So we have what? P plus p over 5 everything equal to 150. Of course, we need to multiply all through by the LCM of the denominator, which is 5. So if I multiply through by 5, so I'm going to be getting just a straight line equation instead of having fraction. So multiply through by the LCM of the denominator. So we have 5p plus, when I multiply p over 5 by 5, it's going to give us plus p equal to 150 times 5 is going to be 750. And of course, 5p plus p is 6p. So 6p equal to 750. Now, how do we now get p? We have to divide both sides by 6. So which is going to be giving us p equal to 125. So p equal to 125. And recall that we have already said we should let p equal to 5 raised to the power of x. So we are going to be bringing it back. So recall that your p equal to 5 raised to the power of x. Now let us bring back this. And p is also 125. So you can say 5 raised to the power of x equal to 125. So 5 raised to the power of x equal to 5 raised to the power of 3. Because 5 raised to the power of 3 is 125. Then equate the power. Therefore, we can say x equal to 3. And this is how you solve problems like this. So do not forget to like and share. Then anticipate for more problems. You are great.